Hello everybody, this is MaEd 28361 part 3 given to second year, first semester, deals on special limits. The last two parts deals on the infinity limit and limit at infinity. So special limits are limits. When we substituting directly, they give us the indeterminate values such as 0 over 0, infinity over infinity, 1 power of infinity, and extra. But we recommend to have a specific value at the approach certain value. This is why they are called special limits, and we have the following examples that advise always. Okay, one is the limit of over x is the value 1, and the second one limit of 1 minus cos x over x as x approaches 0 is 0. The third one, a power of x or somewhat exponential function minus 1 over x as x approaches 0. This is equals with ln a. The fourth one, as x approaches infinity. This is an example of the limits from at infinity. That's why 1 plus 1 over x the whole over x. Then its limit or its approaches to e. X approaches 0, or 1 plus x the whole over 1 power of x. The same is true. This gives also a, which is the same thing, both of them, as alternative. That the values in both cases, which is e, also here is e. Again, the same is true. As x approaches minus infinity, the same thing. So in general, number 4 and 5 are the same things. That's why as x approaches infinity or as x approaches minus infinity, the same thing, the limit approaches to both of them e. So when you observe these 5 limits are called special limits. Why it is called special limit is when you substitute directly, it gives the indeterminate values such 0 over 0, infinity over infinity, and 1 power of infinity, 1 power of infinity, and extra. There are such numbers are not element of real number, please, but they are called indeterminate. It does not say something or it does not give any information, so they are called indeterminate values. If you as we have advised in last part, while evaluating different limits, if we substitute directly into the limits, if one value of this happens, it needs factorization or rationalization or other techniques. But here, if it is one of the member of these special limits, so we will apply those all one of them. So when you observe, if you substitute, for example, the first special limit as x approaches 0, sine 0 is 0, also over 0. Then 0, this gives, when you directly substitute, 0 over 0. But this is not element of real number, which is indeterminate, but the value is 1. The value is 1. This is why what you call special limit is. The same thing, this happens for number 2. This happens for number 2, for example, as x approaches 0, then a power of a power of 0 is 1, a power of 0 is 1, and 1 minus 1 is 0 over 0. This is indeterminate, but the limit approaches to ln a, same thing. But for this one, if you substitute as x approaches to infinity, then 1 over infinity is 0, 1 plus 0 is 1, 1 power of infinity, which is, this is an example of, for this one, 1 power of infinity is not 1, which is indeterminate, please. But the limit is e, the same thing for number 5 and so on. So, of these special limits, the first one we can prove the first one using the Sixing theorem. What it says, Sixing theorem. Suppose you have three functions f of x, g of x, and h of x, where their limit is exists at a point such that it satisfies this condition: f of x is less than g of x and less than or equal to h of x. Then, if the limit of f of x is L, it approaches to L, and the limit of the g of x approaches to L, then the limits of h of x is approaches L. That's why the middle. We have three functions. This is the middle one. Therefore, then example, if we can check this one. At the place of f of x, if I have taken 1, at the place of g of x, let's say I have taken sine x over x, and this one is less than or equal to cos x, then the limit of f of x is 1, the limit for f of x 1, and the limit for h of x, which is cos x, as x approaches 0, is 1. Again, then the function at the middle, which is sine x over x, will be 1, as x approaches 0 is also 1. This is the first example of the special limit. This is why the limits we say 1. So having these 5 or 4 examples of special limits, so we will see different examples which satisfy or calculated better up or the special limits for the next one.